Okay, question number 1. You may need data booklet, means periodic table is needed in question number 1. Is, I think, very easy question. What number of protons, neutrons, and electrons are present in the ion disk? So from the periodic table, we know the atomic number is 26. Atomic number means number of protons. So eliminate the wrong options. So 26 proton, because 3 plus means deficiency of 3 electrons. So 23 electrons. A is the answer. Question number 2 is about for which hydrocarbon are the molecular and empirical formulae are same. Okay, it's very simple. C4H10. So to CH2 is the empirical formula. A wrong. Ethane. C2H6 is the molecular formula. CH3 is the empirical formula. B wrong. It's possible for, and this is also alkene, pentene C5H10, and its molecular formula is empirical formula is CH2. C wrong, so obviously D is the answer. How is D answer? C3H8, so it cannot be simplified, right? So keep in mind the shortcut. Alkene is not possible. Okay, so it's not possible. C. So try A, B. If A and B are wrong, then the answer will be the D. Okay. Okay. Question number 3 is about Hess's law. There are this type of questions in which two equations are given, and you have to make, with the help of two equations, you have to find the enthalpy change of reaction of this. There are two methods. One is making Hess's law cycle, that how to use these two equations. See, the products are almost same. Only here 2 NaCl, rest of them are same. So if I write the products here of both equation, NaCl plus water plus carbon dioxide. Suppose, okay, I write like in a way that should be in between these two. NaCl plus water plus carbon dioxide. Okay, sodium carbonate, and the value is minus 96.59, because this is 2 mole and this here it is 1 mole. For 1 mole from sodium hydrogen carbonate plus HCl, obviously the 2 mole of HCl. So the product is minus 38.97. So for 2 mole, it will be 2 multiplied by minus 38.97. This we have to find. Now remember, A, B, C. Hess's law says if you take two roots, okay, root number 1 is this one, and root number 2 is this one, A to C and C to B. The total enthalpy change will be same. So if you apply this, so X is equal to 2 into minus 38.97 plus, when you go this way, this arrow is flipped, so the sign is also changed. 96.59. So the question number 4, the answer will be C. Okay, there is another method. to solve this question. Method 2. Method 2 is with the help of these two equations, you can make this equation. So if you feel method 1 is difficult, so use method 2. But that you have to make little plan. So in equation 1, you are given sodium hydrogen carbonate for 1 mole, but you have in the required equation, you have NaHCO3 2 moles. So multiply the whole equation by 2. Whole equation. When you multiply the whole equation by 2, the equation will be like this. 2HCl, 2NaCl, 2 water, 2 carbon dioxide, and 2 into minus 38.97. Okay. Now, and then add with the second equation. So, sodium carbonate, before adding, you have to make plan. The sodium carbonate in the required equation is given in the product side. See? But in the given equation, it is on the reactant side. So flip the equation. When you flip the equation, so can we flip the equation? The question, yes. Reactant side to the product, product side to the reactant. So what is the rule? Rule is the delta H sign will be flipped. Minus, instead of minus, you will have plus 96.59. Okay. Now you add. So in the method 2, you have to add the given equation, but before adding, you have to see whether you have to multiply the equation or divide the equation before adding, or you have to flip the equation. Okay, that you can know from by looking at the required equation. Sometimes required equation is not given, you have to make it. So 2 NaCl in the product side, 2 NaCl in the reactant side of the other equation, these things are subtracted. So the overall equation will be like this. 2HCl and 2HCl cancelled. Okay. 2 water on the product side, water on the reactant side. So it means 1 water will be left because they are subtracted. 2 carbon dioxide on the product side, 1 carbon dioxide on the reactant side. So 1 is left on the product side. So one more thing is sodium carbonate. It means our method is correct. We got the required equation. So you add these two and you will get the same answer, that was C. Okay. So MCQ number 5 is about redox. So you have to, in this question, the oxidation state of vanadium and sulfur you have to mention. Okay, so VO2 plus is like this. 1 oxygen minus 2, 2 oxygen minus 4. What charge should it have? So the overall should have plus 1. Okay, so obviously plus 5. Plus 5 minus 4 plus 1. Sulfur dioxide, 1 oxygen minus 2, 4, and sulfur is plus 4. Okay, and so if you see the option, so A and B wrong. Vanadium oxidation state changes to plus 3 from plus 5, so D is the answer. But sulfate also overall minus 2, 1 oxygen minus 2, 4 oxygen minus 8. What charge should that sulfur have? So the overall should be minus 2, so obviously plus 6. Question 6 about equilibrium. Equilibrium Caie question. In Caie expression, we don't mention solid. Solids because there is no concentration of solid. If something is undissolved solid, so there is no concentration. We cannot say concentration because it's not dissolved. So we do not write AgCl. What are the units of Kc? So Kc is obviously, suppose whatever this is, this whole thing is one thing. I suppose it is A. A, I mean, this is 1, so mole per dm cube. This is also mole per dm cube. And in denominator, ammonia mole per dm cube square. Okay. So obviously it is cancelled out. So no units. Again, solids are not expressed in Kc expression because we cannot find the concentration. And for Kp, we do not even mention liquids. Solids and liquids are not mentioned in Kp expression. Question number 7. Okay. Which volume of nitrogen measured at room temperature and pressure will be produced by decomposition of 150 grams sodium azide? Okay. So you have to find the relative molecular mass of sodium azide. Okay. Okay. Question number 7. You have to find the volume of nitrogen stoichiometry from 150 grams sodium azide. So we can make it simpler is mass volume relationship. If we just divide the whole equation by, we don't need this, by 2, so it will become 1.5. So 1 mole NaN3, 1.5 mole nitrogen. Because NaN3 mass is given, keep it in mass. 23 plus 3 into 14 is equal to 42 plus 23, 65 gram. And convert this into volume because the answer is in volume and question is all dm cube. So, and the question is also about the volume. So 1.4 into 1.5 into 24 because 1 mole 24 dm cube. So 1.5 mole means 1.5 multiplied by 24 dm cube. So 65 gram NaN3 produces, this is 36 dm cube nitrogen. Question is 150 gram N3 produces how much? So obviously the answer will be 83. B is the answer. Question 8, I gave to many students to do it shortcut, and most of the genius students also had problem in this question. So I have 2 ways to explain. One is very shortcut because the question is a stable ion has been produced by a research chemist. Which structure is most likely to show? Keep in mind that nitrogen is in group 15 or previously group 5. It has 5 electrons in the outermost shell, 3 unpaired and 1 paired. First thing. Even if you know this question will be solved. Second thing, normal valency of nitrogen is valency is 3, but to understand completely this question, you should know if nitrogen is plus, it means it's like group 4. It has 4 electrons in the, so it makes 4 covalent bond. Like in ammonium, it makes 4. So it's like carbon, nitrogen is plus charge. It's like carbon. Or nitrogen can make plus 4 bond like this. Or nitrogen can make 4 bond like this. 1 triple and 1 single. Okay. Okay. And the second thing is you should know if nitrogen is minus, so it's like oxygen because oxygen has 6 electrons in the valence shell. So now it makes 2 bonds. Okay. If you know this, then it's very easy to understand this question. So nitrogen plus form, it makes 4 bonds. Nitrogen minus, 2 bonds is similar to oxygen, similar to carbon, and nitrogen valency is normally nitrogen neutral atom valency is 3. It makes 3 bonds. So, to solve this question very quickly, there's a hint because stable ion, uh, this is not possible because you see, nitrogen electron is like 1, 2, 3, 4, 5, and it cannot form like 6, 7, and this is not stable. Okay, all the 5 electrons of nitrogen remain here. Here, same, all the 5 electrons of nitrogen are not involved in bonding. Here also, all the 5 electrons of nitrogen are not involved in bonding. It's not possible. So, C is the answer. Okay, but the actual way how to draw N5, I show you there are 6 ways to draw N5. I show you more elaborately for those who are very enthusiastic to learn more. So for those who want to know enthusiastic learner, so there are 6 ways to draw the structure of N5 plus. One of the ways like that, one and first you draw 5, 1, 2, 3, 4, 5. Okay, then one is like this one is plus because making 4 bond. This one is making 2 bonds, so it's minus. Again, this one is making plus. So overall, there are 2 plus and 1 minus, so there is plus. There is one way. There are more ways. Suppose you can make like this also. First 1, 2, 3, 4. The first one, double bond means this one is making also double bond. So this making 4 bonds, so plus. This making 2 bond means minus. And this nitrogen is neutral because making 3 bond. This nitrogen plus, so 2 plus, 1 minus, overall plus. Like this, I would like to share and I did some little research also. So it showed there are 5 ways to draw, 6 ways to draw the structure. Okay, 1 minute. Like this, yeah. Look, 1, 2, 3, 4, 5, 6. There are 6 ways to draw N5. And this arrow means resonance. Resonance means the position of electrons in the outer shell changes. This is also possible second, third, fourth, fifth, sixth. Okay. You need not to know these, but it's for those who want to know little more. Okay. Question 9 is about states of matter. I think it's quite easy. So 1.8 gram mass is temperature is in Celsius. You add 273. So and this is pressure multiplied by 1000. So it will be in Pascal. Volume is required. PV is equal to nRT. N is equal to PV upon RT. So P is 200 into 10 raised to power 3. Oh, sorry. Um, oh, this we need V. So we need V to find PV is equal to nRT, and volume is nRT upon P. Number of mole is the mass upon molecular mass for water. R is 8.31, T is 227 plus 300. This one is 300. Okay, 500. Sorry. Divided by pressure is 200 kilopascal. So must be in Pascal. So the answer is 2 into 10 raised to power minus 3 meter cube. So B is the answer. Okay, states of matter question, and it was quite easier. Okay, look at the question number 10. To understand this question, C is not the answer. Okay. You should know some two things. One, you must know how to find the oxidation number. Second thing, how to balance the equation by using oxidation number method. First, I told all my students to memorize that MnO4 minus KMnO4 or MnO4 minus, they both have +7 oxidation state of magnesium, and it is oxidizing agent always, so it will be reduced. Okay, in C2H6O2 minus 4, one oxygen is minus 2, two oxygen minus 4 plus 6, 6 minus 4 plus 2, so this will be minus 2 on 2 carbon, on 1 carbon it is minus 1. Okay, in C2H4 it is plus 4 and in minus 4, and on 1 carbon it is actually minus 2. Okay, so right here oxidation state +7, and here on 1 carbon it is minus 2, and here on 1 carbon it is minus 1. Even you don't know this, you can do very quickly this question if you know basic rule. Remember, basic rule is how to balance oxidation equation by oxidation number. Suppose A plus 7 plus B 2, which is minus 2 on 1. A is 2 plus B2x. Here B, suppose B2xyz, and here B is minus 1. So the oxidation change in the oxidation state from A plus 7, A plus 7 is to A plus 2, it is 5. So you multiply this one by 5. The change in oxidation number of the oxidizing agent, whatever it is 5, and you multiply the other one, which is suppose this is oxidizing agent, suppose this is reducing agent. So multiply this one by 5. And what is the change in oxidation state here? -2 to -1 on 1. There are 2. So the change in oxidation state is 2. So you multiply here 2. Okay, and later you can balance. Got it? More simply, if you say, so what is the oxidation number change here? It was 2, right? And if it is written 2 here, it means there is change in state here is 2. from here to here. If it is, you are given here too. So look at the question here. Here it is given to, okay, there is no change in oxidation of hydrogen and oxygen, because oxygen and hydrogen it changes if there, hydrogen changes if there is metal, then hydrogen is -1, oxygen if there is peroxide or there is exceptional case. Otherwise, there is no change in oxidation number. So if this one is 2 here, it means there is a change in oxidation state from here to here is 2, which is why the change in oxidation number on carbon is multiplied here. So what is the change in oxidation number here? 5. So you multiply this one by 5. Okay. Got it? Okay. Now, how to find the answer C? Right. If this is 5, this must be 5 because there is carbon is only one place. You balance carbon. Now, hydrogen is, manganese is balance. Oxygen you can balance first. 5 times 2, 10. 2 times 4, 8. So here will be 2. Now oxygen balance. Oxygen balance, manganese balance, carbon balance. Okay. Now hydrogen is left. So hydrogen is here 5 times 6, 30. Here how much? 5 times 4, 20. And 2 times 4, 24. So how much is left here? 6. So D is the answer. Okay. Very shortcut. Shortest way you see here 2. So it means there's change in oxidation state from here to here is 2. So manganese plus 7 is always there in MnO4 minus, here is plus 2. So the change is 5. You multiply here 5. Okay, so now balance. This side 5 and this side 5. Balance. Then oxygen here 10. Here it is 8. So there will be 2. Hydrogen here is 30. 20, 24. So C will be 6. Balanced. Okay. The charges must also be balanced on both sides. So you can see the charges balanced here. Suppose if I on both sides of the equation. Okay, charges are also must also be balanced. So on reactant side, 6H plus 6 plus 6, this one. And 2 into -1. Okay, so -2. So plus 6 minus 2 is plus 4. So let's see, this side is plus 4 or not. Yes, 2 times 2 plus 4. So charges also balance. It means our equation is correct. Okay. Number 11. It's about equilibrium, and you can do it like O-level based question. You must know that there is no effect of catalyst on the yield. Equilibrium yield. So eliminate the wrong answer. Catalyst cannot increase the yield. Okay. So you know this 2 and 1 mole, here it is 2 mole. Increasing the pressure, shift the equilibrium towards less number of mole. Product side has 2 moles. High pressure increases the yield. So B is the answer. No effect. We don't even need to see the temperature because that's the answer. 12. Period 3. X and Y are oxides of element on period 3. Okay. 1 mole of X is added to water. The solution formed is neutralized by exactly 1 mole of Y. So, in general, aluminum oxide, because aluminum oxide is not soluble in water, is amphoteric. It reacts with both acid and base both. Okay. So just for a moment, we just eliminate these two options. Let's start with C. P4O10 plus water, so H3PO4. Okay, so 1 mole of phosphorus oxide reacts with 3 mole of with water to forms 3 mole of phosphoric acid. Okay. Okay, and it's not even balanced. Okay, sorry, 4 to the 12, 6. Now it's, and if you react with sodium oxide, it will not need 1 mole of water. If you react with phosphoric acid, the question is 1 mole of X is added to water solution formed is neutralized by exactly 1 mole of Y. Okay, so this will not, is acid, metallic oxide is base, so this does not come true on this fact. Let's try part D. Sulfur dioxide reacts with water to form sulfuric acid. 1 mole of sulfuric acid react with 1 mole of sodium oxide to form 1 mole of sodium sulfate. Okay, plus H2O. So this is true. D is the answer. Okay. 13. Little easier. Compounds is insoluble, underline, in water, but soluble at low pH means in acid. Low pH means acidic. So barium chloride wrong, because all chlorides, barium chloride is soluble in water. Barium hydroxide is soluble in water. Barium sulfate has no reaction in low pH. Barium carbonate, because carbonate reacts with, all carbonates are insoluble except the carbonate of group 1 and ammonium carbonate. Except these carbonate, all carbonates are insoluble. So it is insoluble, and carbonates react with acid also. So A is the answer. Question 14, very frequently asked question. So this is hot concentrated NaOH. Chlorine is +5. You must memorize this question. Okay. So which statement is correct? Oxidation number of chlorine and hydrogen both change. Wrong. Hydrogen oxidation changes only when there is a metal. So hydrogen is not attached with metal. Hydrogen is attached with O. Oxidation number of chlorine is wrong because it's +5. If aqueous sodium hydroxide is cold, the reaction is yes. Instead of NaClO3. Yes, that's correct. Then here, with cold, NaClO is formed. 14, C is the answer. 15. Ammonium nitrate is put into a test tube solution. X is added. The resulting mixture is warm. Gas is given out. Tested damp red litmus paper. The litmus paper changes to blue. It means gas is ammonia. Okay. What could be the identity of X? Usually remember a rule. Ammonium plus alkali. Ammonia gas is given out on warm. Okay. So alkali is base. Base accepts proton. Okay. So which one is correct? C, D wrong, because acid does not react with ammonium salt to form ammonia gas. Base. So base accepts proton. In short mnemonic, I asked student to memorize BAP BAP. Base accepts proton. So B is the answer. 16. Again, group period 3, and because it's very easy, so I can just directly jump into the answer. Sodium oxide reacts with water, yes, to form sodium hydroxide. Magnesium oxide slightly react with water, yes. Aluminum oxide, no reaction with water. This is true, but magnesium oxide is not amphoteric. Why this one is wrong? Aluminum oxide is not simple molecular. It does not have low melting point. D is the answer. 17 is again about the gases. You must know about group 2, nitrate. This is the equation. When nitrate is heated, you get oxide, nitrogen dioxide, and oxygen. Half oxygen for 1 mole. This is the equation. Okay. So, calcium nitrate here. Here you will get nitrogen dioxide is acidic. Acidic means it turns damp blue, litmus red. So changes to blue is wrong. So changes to red must be there. And this gas is oxygen because it is not dissolved in water. There are two gases. So C is the answer. Flame burns more brightly in oxygen, helps in burning. 18. How does concentrated sulfuric acid behave when it reacts with sodium chloride? You may see one of the equation. There are two ways you can write the equation. NaHSO4, one way is this, plus water plus NaCl plus HCl, sorry. And there is no change in oxidation state. Sulfur also plus 6, sulfur also plus 6. So everywhere where there is reducing agent, oxidizing agent is wrong. Sulfuric acid, if there is no change in oxidation state, reaction is not redox. A is the answer. Even in some books, they write the product like this, Na2SO4 plus HCl. Even here, there is no change in oxidation state. So as an acid only. Okay, if there is no change in oxidation state, means it cannot act as oxidizing or reducing agent. Number 19. Which statement about nitrogen or compound is true? In the harbor presses, the temperature is kept high. Up to here is correct, but half of the statement is correct. To give a good yield is wrong because temperature is kept high for to increase the rate of achieving the equilibrium, not good yield because it's an exothermic reaction. Exothermic reaction means increasing temperature shift the equilibrium towards backward direction, so yield will not be high. Nitrogen gas is unreactive because a strong nitrogen double bond. See, nitrogen gas is less reactive. Less, not unreactive, less reactive. Strong nitrogen triple bond. Double bond is written, is triple bond. C is the answer. Ammonia will react with carbon monoxide. O level also we study this reaction in catalytic converter plus carbon dioxide. The formula of ammonium sulfate is wrong. The formula of ammonium sulfate is not this actually. Ammonium has +1 and sulfate is -2. 28. Which pair of compounds are functional group of or isomers of each other? If you remember a rule, then it's easier for you. Carboxylic acid plus ester, functional group isomer. Aldehyde plus ketone. Functional group isomers. Alcohol plus ether. Ether usually we don't teach you, but just tell you that oxygen has both side alkyl group. So alcohol and aldehyde are not functional group isomers. Okay. Let's see. Alkene and both are alkene, not functional group isomers, position isomers. Propyl amine is different and nitrile is different. This is propyl amine and propane nitrile is this one. So both are different. B is the answer. Ester and carboxylic acid. Why? Ethyl propanoate. 2 carbon here, 3 carbon here. Total how many carbon? 5 carbon. Pentanoic acid also 5 carbon. So both are functional group isomers. No need to draw it, but you can draw like this. Ethyl propanoate and pentanoic acid because C5H10O2. Both should have C5H10O2. Yes, this is C5H10O2. Carboxylic acid and ester both have general formula CnH2 and O2. Okay. 21. Butane nitrile we have to prepare. So first you write what is butane nitrile. We have to count carbon of cyanide also. If you take, there is no substitution reaction in halogenoalkane and HCN, no reaction. With NaCN it is there because HCN is a very weak nucleophile. So bromine is substituted by cyanide and we will get this compound. B is the answer. Why not C? No reaction. Halogenoalkane plus HCN, no reaction. 1, 2, 3, 4, 5 carbon will form here. This one will form pentane nitrile. Its name is pentane nitrile. Keep in mind, we also count this carbon of cyanide also in IUPAC. So D also wrong. Number 2. At ethane dioic acid is given. Reacts with ethanol. It means in a few drops of concentrated sulfuric acid to form a diester. It means here OH is removed and you form ester. Here OH is removed and you form, oh sorry. Here H is removed and you got alkyl group, ethyl, ethanol. So ethanol, ethyl group comes here. Okay. So what is the structural formula if you write this proper way first? CH3, CH2O, then CO, then CO, then O, then CH2, CH3. So look, A is wrong. It's not like this. B looks correct. Yes. This is this. Okay. 23. About infrared spectrometry. You must know about the how to use data booklet. But I tell you some answer. Cyanide, C double bond O is very common, around approximately 1700. Approximately, you can see so it is there. Cyanide is around 2250. There is no cyanide. Cyanide. Cyanide is not there. So CO is present. This is also wrong. This one is CO, around approximately 1700. In um, this question, first we have to know that this is a addition polymer. Okay, addition polymer. So the basic thing is, if you know that this is a monomer, then you must know how to form polymer, like C3H7, and here you have C2H5. Actually, its monomer is like this. So if you know this monomer, and you can form the polymer, right? CH3H, C2H5, C3H7. Surprisingly, this is the monomer of this compound. So if you know this fact, now how to apply here? First thing, we have to find the basic repeating unit here. So what is the basic repeating unit here? This is, you see, repeating. If you think it, if it is here, this, then that will be the basic repeating unit, right? So now you got. So if I make the monomer like this, then it will be easier for you to understand. This CH2, CH3 is a double bond here. This is a monomer actually. Carbon 1, suppose 2, 3, 4, 5, 6, 7, 8, suppose. So there are 8 carbon in the monomer. It is not IUPAC nomenclature I'm doing. This is the monomer. So the carbon which is attached, that has been double bond, has one methyl group. I mean, the carbon which has double bond, one carbon has methyl group and hydrogen, because there is nothing here, means hydrogen. The other double bonded carbon, which is carbon number 3, has one CH2, CH3 group, and one, this 1, 2, 3, C3H7 group. So apply this here. Let's start with A. These double bonded carbon having one methyl group. Yes. This is another double bonded carbon having, this part is C2H5 and this part is C3H7 isopropyl. With the word isoprop we don't use in A level, but it is like this. Okay, secondary propyl also it is called. So A is the answer. Why not B? Because the double bonded carbon has the one methyl group, one ethyl group, and one ethyl group also, which is wrong. The methyl group containing double bond has one H. Okay, so apply this rule here. So it's also be wrong. The double bonded carbon has methyl group and big chain, wrong. The double bonded carbon has a long chain carbon and the here propyl group, sorry, ethyl group and hydrogen, which is not possible here. So A is the answer. Okay, this one is flipped here. So learn the basic rule. The repeating unit you identify, and then you raise the double bond. You just made the double bond, and then see what is on the double bonded carbon. One valency of the double bond, one double bonded carbon has methyl and H. The other double bonded carbon has ethyl and propyl. If you follow this rule, then it's easier. Okay. Question number 26 about 25 about isomerism, about isomers, and you have to consider structural plus stereo. There is no shortcut for this. You have to do it for C5H10. Number one is easier to save your time. Pent one in, and pent one in because it is like this. So double bonded has two same carbon, so there is no cis trans isomerism. But 1, 2, 3, 4, 5. Pen 2 in. So from pen 2 in, you get cis and trans both. Number 3. There is no pen 3 in because if you draw the double bond here, the number will start from right hand side and it will also be pen 2 in. So what we have to do, we have to keep the double bond here and make a branch. So again, this double bonded carbon has two methyl group. Sorry, this double bonded carbon has two groups same, so no cis trans. Keep the double bond here and keep the alkyl group for like move the alkyl group. Again, this because we'd have to make isomers, so we don't have to satisfy all valency. Again, there is no double bonded carbon. Sorry, there is no chiral carbon or neither chiral carbon because these two groups are same, and there is no cis trans also because the double bonded carbon has two groups same. Okay. So now any other possibility? Yes, one more possibility is there. You move the double bond. Move the double bond and keep the branch on the second. Again, there is no, yeah, there is a double bond here. First, we move the branch and we kept the double bond on carbon 1. Now we move the double bond. So if the question were only about structure, though there would be 5. But the answer is structure plus stereo. 1, 2, 3, 4, and number 2, 5, 6. Keep in mind, if we are considering the stereoisomers, we don't consider its structure. We don't count its structure because structure is any one of them. So the answer is 6. You must know that alcohol, for question number 26, the reaction of dry HBr, excess of dry HBr is reacted with compound Y. Okay, alcohol also reacts with HBr. Yes, substitution reaction takes place. Br substitutes OH. And in alkene also reacts with HBr and addition reaction takes place. One carbon gets H, one carbon gets Br. If you apply this rule here, you must know that HBr will be substituted, OH will be substituted. So eliminate the wrong answer. B and A are wrong because OH still same. OH must be substituted. So C is the answer because the OH is substituted. This carbon also got Br. Okay. So that sorry, this carbon also got H and Br. And this is double bonded carbon where it is CH2. So CH2 will become CH3, and there will be Br here, and there will be no double bond, right? So which is why C is the answer. Why D is wrong? Okay, D is wrong because if you look at this structure, so this is CH2, CH2. So if you add HBr, it will be have H. It will become, because the carbon having more hydrogen, according to Markovnik's rule, gets the hydrogen. And this carbon get bromine, which is why C is the answer. Okay. 27. Which reaction would produce propanoic acid as one of the product? So this hot concentrated KMnO4, the double bonded carbon, if there is H, sorry, if there is H on the double bonded carbon, so this H converts into carboxylic acid. So A is the answer. It's possible. Why not B? Ester on hydrolysis, this part form alcohol, and this part with NaOH it forms salt. Ethanol form ethanoic acid on oxidation. This is ethanol reacts with HCN. First it forms OH and CN. And when you hydrolyze, CN will form at carboxylic acid, but OH will remain there, which is why it's also wrong. The question was only propanoic acid, which is why A is the answer. 28. Lithium aluminum hydride, you must know LiLH4, and you must know it is a reducing agent. It's a reducing agent. And reducing agent reduces carboxylic acid into primary alcohol. And also ketone into secondary alcohol. So it means these two groups should be reduced. Carboxylic acid, C and A, 100% wrong because carboxylic acid are still there. B is wrong because ketone is still there. Ketone must be reduced to secondary alcohol and carboxylic acid to primary alcohol. D is the answer. 29. Which is the skeletal formula of the compound when formed when this reaction is heated with dichromate? When it is heated with dichromate, double bond does not break and CH2OH is oxidized to carboxylic acid. 1, 2, 3, 4. Okay, and the 2 and 3 has double bond also. So B is the answer. Sorry. Was I too fast? B is the answer. 1, 2, 3, 4. Look. 38. Two of the ring X and Y contains a double bond. Which row is correct? Number of ester group. This is ester. This is ester 2. So 1, 1 is wrong. Number of ester group 2. So either C or D. Planar, because double bond and single bond, it cannot be planar. So D is the answer. Planar means all the atoms should be on one plane. It's not possible here. That's a ring which single and double bond is not possible. 31. Now remember the option. If 2 is wrong, then only D is the answer. Carbon and nitrogen, for this question is a trick. Carbon and nitrogen are adjacent in the periodic table. Which properties do the both have? There is an empty 2p orbital. You see carbon is 1s2, 2s2, 2p2. But nitrogen 1s2, 2s2, 2p3. No empty orbital. 1 is wrong. No empty in nitrogen. They say empty orbital in each empty 2p orbital. If 1 is wrong, no need to read 2 and 3. 2 and 3 both will be correct. Okay, but you can read principal quantum number means shell. Many students, they don't know. Highest occupied shell is 2. Yes. They can form compound in which their atoms form 4 bond. Yes, carbon makes 4 bond, and nitrogen can also make 4 bond, like ammonium also the compound, or nitrogen can make 4 bonds. Sorry, nitrogen can make 4 bond like this. But nitrogen when makes four bond, I explain you in question number 8, it has plus charge. Hydrogen bonding, if it is greater, it means there will be greater viscosity. There will be greater boiling point because you have to break. There will be greater surface tension. So A is the answer. All 3 correct. 33. Which standard enthalpy change of reaction can be? This is the enthalpy change of formation of carbon monoxide. Yes. No, it cannot be combustion because standard enthalpy change of combustion means complete combustion. It's understood. Standard means combustion means complete. So 2 is wrong, 3 is also wrong. It's not atomization either. So only one correct means D is the answer. 34. When there is a not in the question, you must write not. What will increase the rate of this reaction but will not change the Boltzmann distribution curve? Keep in mind the Boltzmann distribution curve is, suppose there is activation energy. Activation energy is here now. Curve does not change. Addition of catalyst does not change the cat. Okay. Okay. Oh, sorry. Does not change. Sorry. So this is correct. Addition of catalyst does not, because it says does not change the Boltzmann distribution curve. Yes, it does not change. If you increase the distribution will be almost similar. If you increase more particles, okay, it will also not change. If you increase the temperature, if you change the temperature, the curve will be changed. The curve will be like this. If you have low temperature and with high temperature, the curve will be like this. Okay. So not change the curve means 1 and 2. 35. Astatine is in the last member of groups 17. Fluorine, chlorine, bromine, iodine, astatine, all are diatomic. Is it dark colored? Yes. Is more powerful? No. Is less. Fluorine is the most powerful oxidizing agent, then chlorine, then bromine, then iodine. Is hydride is more thermally stable than HBr? No. HAT. Thermal stability of hydride decreases down the group because the bond length increases, so bond energy decreases. So it decomposes more easily down the group. Okay. Only 1 and 2 correct. Sorry. Only 1 correct. Okay. I mean, which is D. Okay. 36, which statement correct? Aluminum chloride dissolved in water to give acidic solution in, we know this in periodicity, period 3. Yes. HCl is formed. Magnesium chloride dissolved in water to give a solution. Yes, it's true. Close to 7 because magnesium chloride is slightly acidic. pH, you can say 6.5 to 6.9. Wrong. Sodium chloride is neutral. B is the answer. 1 and 2 means B. Sodium chloride does not give alkaline solution. It's neutral. 37, you have to revise your nucleophilic addition. Nucleophilic addition in aldehyde and ketone mechanism. Cyanide is catalyst also and as nucleophile also, and it's a nucleophilic addition. Yes, all 3 correct. So A is the answer. 38. Which statement apply to tetrafluoromethane. Sorry, tetrafluoromethane. No, sorry, 38. This one. Yellow PPT with alkaline iodine. You must know which compound does only one aldehyde. This one shows yellow PPT with alkaline iodine triiodomethane test. Okay, there is only one aldehyde. All ketone having this group and all alcohol having this group. The carbon having OH must have CH3, must have H and OH. If you apply this rule here, so one, it is not possible because this is big aldehyde and this OH does not have any H. No H because one valency with OH, one valency with methyl, third with methyl, fourth with this group. One is wrong means 2 and 3 will be the correct option. But how? You see, this carbon having OH has H also, methyl group also. It's like this 2. So this group is needed. As I mentioned, yes, it is there. And this one, third one, why it is correct? Because the carbon having OH has H also and CH3 also. It's like this. So this is needed for iodoform test. We also call alkaline aqueous iodine. So 2 and 3 both are correct. So which is C. Number 39. Tetrafluoromethane. Rapidly decompose? No. Carbon chlorine bond decomposes. It is less harmful to the ozone layer? Yes. Carbon chlorine bond breaks down homolytically in UV light, forming chlorine free radical. Chlorine free radical react with ozone and depletes ozone. It's non-polar? Oh, yes. Why it's non-polar? Many students think carbon fluorine bond is polar because of the high electronegativity of fluorine. But it's wrong due to the symmetrical structure. Tetrahedral is symmetrical if all four groups are same. So its dipole moment is 0. Dipole moment is the overall polarity in a molecule, which depends on the shape of molecule also. If the shape is symmetrical, it's like a vector quantity, so it's cancelled out. So we have to know that which shape is symmetrical, which not. It's a big detail. Trigonal planar symmetrical, tetrahedral symmetrical. If all this is symmetrical, this is symmetrical, this is symmetrical, this is symmetrical, linear. Okay. Even SF6 also symmetrical. Third is last question, which statement of comparing ethene and ethane. Ethene and ethane are correct. The bond angle in ethene are larger. Ethene has 120 degree, which is correct. Ethane has 109. Ethene reacts with more quickly with bromine in dark. Yes, decolorizes aqueous bromine. Complete combustion of, look here, this is ethene. When it reacts with oxygen, it forms 2 mole of carbon dioxide. Even ethane, it formed 2 mole of carbon dioxide because it has 2 here. Complete combustion of 0.01 mole of ethene and ethane produce same volume of gas produced at room temperature and pressure, means not about water. No water, because water is not gas. They are talking only about carbon dioxide. Yes, 1 mole, 2 mole. 1 mole, 2 mole. So obviously 0.01 mole also, they form the same 0.02 mole gas. Same volume also, obviously, because the mole, 1 mole means 24 dm cube. Got? Okay. All three are correct. That's all for today. If you have any question and suggestion, please ask. in the comments. Anyone, any suggestion? I'm a learner. Still, after 25 years of teaching, I'm enthusiastic learner. I will appreciate if you just comment positively, and if you just let me know if there is another method, quick method of solving any MCQ, short or better way to explain, or let me know where I have need improvement. Okay. Assalamu alaikum.